In this session, we are going to introduce another kind of measures for clustering validation called relative measures. We already introduced external measure when we have ground truth. We also introduced internal measure when we try to measure the intra-cluster, they are very compact, and inter-cluster, they are far apart. Okay. Now we want to look at what is relative measure. The relative measure actually is trying to directly compare different clusters, especially for those obtained using the same algorithm but different parameter setting. For example, like if we all use k-means to cluster a group of things, but in that case, we want to measure for different cluster instantiation, which one give you the best clustering, or a different case for k from 1 to certain number, which k gives you the best clustering. In that case, we will measure this using relative measure. And one interesting measure called silhouette coefficient can be used for relative measure. Okay. But actually, silhouette coefficient also popularly used as an internal measure. That means we will be able to use it to check cluster cohesion and separation. So I first introduce it as an internal measure before I introduce it as an external measure. Okay. So for every point x sub I, we can calculate its silhouette coefficient s sub I. Okay. How we calculate it? We use this formula. This formula actually mu sub n is the mean distance to the point of its own cluster. Simply says, if we find this point in the blue cluster, okay, we want to see this x sub I actually to all the points in its own cluster, that distance, we want to average them. We get a mean distance, that's mu sub in. Then what is mu sub out mean? That means we want to see this blue point to its closest cluster, which is this orange one, to its closest cluster. All the points in its closest cluster, we calculate their mean distance. That's this value, mu sub out mean. Okay. Then what we want to see is their distance. You probably can clearly see for any point x sub I, you want the internal distance is reasonably small, but even to its closest cluster, this average reasonably big. So to that extent, this value usually should be positive, and the more positive, the better. Okay. Then we will normalize it. We divide by the max value between this mu out mean and the mu in. And if we pick up the two, so it simply says that this division must be smaller than 1. But on the other hand, if it's closer to 1, simply says it's better because the internal is very compact. To the outside is reasonably big. This is only for one point. What is for the whole clustering? Okay. So silhouette coefficient for the whole clustering is you take all the endpoints, you calculate everyone's silhouette coefficient s sub I from 1 to n, you calculate all the s sub I, you normalize it, you divide it by the number of points n, you get the whole clustering's silhouette coefficient. Of course, this silhouette coefficient, if it's closer to +1, it implies good clustering because the internal one to its own points is rather close. To the other cluster, even to the closest one, is reasonably far. So we also can use this silhouette coefficient as a relative measure. For example, we can use it to estimate the number of clusters in the data. Say, what is the best k? Okay. We can pick a value that yields the best clustering. That means yielding the high value for SC and SC sub I. For example, you can thinking about you did a lot of clustering. Okay, for all the eyes, you want to see which one give you the best clustering. That means which one give you the highest silhouette coefficient. Then you can pick up that instantiation, pick that K. So that's the usage of silhouette coefficient as a relative measure.